There's my four states. Okay? If you start here, you go here. If you start here, you go here. If you're over here, you go over here. And if you're over here, you go over here. All right, so now we can say what happens wherever you start. If you start over here, you jump to 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 here, you go 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 here. Notice you never come back to here. Okay? With this particular law. There's something different about this law than there is about the other examples. And all the other examples, well, can anybody spot what's wrong with this? Well, not what's wrong with it, but what's different about it. Well, it doesn't consist of loops. This is true. You can't figure out necessarily where you came from. You may be able to tell where you go next, but you can't always tell where you came from. For example, if you find yourself over here, you don't know if you came from here or whether you came from here. If you're over here, you have lost a piece of information. This is a motion which loses information. It loses information in the sense that you can't tell where you came from. There's no way to reconstruct the past, but you can reconstruct the future, or construct the future. Wherever you are, you're told where to go next. But wherever you are, you don't know how to get back. If you're over here, well, you know you came from here, but then you don't know whether to go back here or to go back here. All real systems are quantum mechanical. The question why some of them suppress the quantum mechanics and you don't see it is a question which we'll try to answer as we go along. But we might ask it at the quantum level, and at the quantum level I think we can give a better answer. I think they're all Newtonian in a sense. Newtonian to me simply means that there's a definite state for a system, that it evolves with time according to a definite law of deterministic. Deterministic. That's the right word. Yeah. It loses the information as to where you came from. The system.
That doesn't, after the first step.
Yep.
That's not a part of the system anymore.
What do you mean it's not a part of the system? The system started here, it went to here, it went to here, it went to here, it went to here.
Anymore, so if you come and observe it at some later point in time, you won't find that point.
You won't find that point ever again, right? Right. But the main point is you've lost the distinction between the two possible starting points, whereas in all the other situations, if you know where you are and you know how many steps you made, you can say where you were. Well, I think for a long, long time, Mr. Stephen Hawking thought that this is the way black holes work, so not so clear. Not so clear. Yeah, so we could, to make such a thing, we could just reverse all the arrows. Here is an example.
It doesn't actually have no exit, it just exits back to itself.
No, this one has no exit.
No, it just exits to itself.
Well, then if I want it to exit to itself, I have to do this.
Yes, that's what I'm just saying.
We could do that, but as I drew it, it had no exit. Huh? But let's think about what it means. I'm not too interested in what here. The question is what happens when you're over here. All right? When you're over here, you have two ways that you could go, and you don't know which way to go, so it's not deterministic. It doesn't know whether to go this way or this way. It might go half the times this way, half the times this way. You might need some statistical rule. 50% of the time or 30% of the time it goes this way, 70% of the time with random statistics. That would be non-deterministic.